Modern supercomputers are undergoing an architectural revolution that involves most of the computing power being located on graphics processing units, or so-called GPUs. To fully leverage these GPU-accelerated systems, software companies must dramatically modify their software. Cascade is doing exactly that with its high-fidelity approach to CFD called large-eddy simulation. Cascade Technologies is a software company, and also a collection of fluid mechanics experts that develop and license high-fidelity multi-physics CFD software. Our software is designed specifically to model turbulent flows in complex engineering applications. A lot of the technology in Cascade software comes out of research that has been done over the years at Stanford University, which is nearby to Cascade's head office in California. Our flagship code is called Charles, and it is licensed to a number of customers and also in use at a number of government customers. Some of the OEM partners we have are companies like Boeing, General Electric, Honda, Solar Turbines, and our government users include NAVAIR, ARL, AFRL, and NASA. We also work closely with GPU manufacturers to ensure that our tools can compute on the emerging platforms in a very cost-effective way. There are a number of elements that are unique to the Cascade solvers, and I'll try to describe those in the following slides. The US government and DoD high-performance computing modernization program have continued to invest in high-performance computing systems. These systems run many important applications that support the various missions of the Department of Defense. More and more, these systems are including GPU architectures, graphics processing units, and they're often referred to as machine learning accelerated architectures. Examples inside the DoD include Narwhal, Warhawk, Gene, Onyx. There are numerous machines with some level of GPU readiness. There is a need now for software that can actually leverage these GPU accelerated systems and provide state-of-the-art simulation and modeling methodologies at dramatically increased throughput. There is a need for state-of-the-art CFD software and CFD software methodologies. The problems that we face are increasingly complex and highly optimized, and it's important to use CFD methodologies that are predictive, that are based more firmly on first principles and less calibrated. Large-eddy simulation is one such approach, where the flows are resolved with a large amount of fidelity. The challenge with these methods, though, is they can be very expensive. They can be computationally expensive. And so it's very important that the current and future investments in hardware that are being made by the Department of Defense can accelerate these simulations and reduce the time to solution and really the cost per solution, so that the benefits of these predictive methods can be realized and impact engineering designs. Our solution for this challenge is to provide that GPU accelerated simulation software. We're developing GPU accelerated versions of our flagship high fidelity multi-physics large-eddy simulation software called Charles. The software allows users to leverage the full power of the GPU investments that have been made by the Department of Defense. The simulations are much faster and equally accurate to the CPU versions for both stationary and moving geometry flows. And the initial focus we've taken is on high-speed flows with applications such as the one you see here on the right, where the NAVAIR team looked at inlet and exhaust flow interactions for the CH-53K King Stallion helicopter. and also rotorcraft aerodynamics and aeroacoustics. Prototype versions of our moving and our stationary solvers are available today. They've been carefully designed with intimate connection with the hardware so that they can leverage the full power of the GPU. We use an approach called resident GPU, meaning that the solver is actually brought down entirely to the GPU to avoid some of the communication latency associated with CPU GPU communication. The software is already in use by engineers in the NavAir group that we work with, and we expect full releases of the software for static solver flows or static flows without moving parts in the latter part of 2021, and full moving mesh capability for rotorcraft in the following year or two. The real benefit of this migration to GPU hardware is increased throughput. The results that you're going to get are going to be the same, whether you're on the CPU or the GPU version of Cascade solvers, but the GPU solvers dramatically accelerate the rate of simulation throughput. This is an example here of how remarkably fast the GPU solvers are, even for these high-fidelity CFD problems. The curve here shows the response of the lift force from a cold start for the JAXA standard model of a half airplane used in the AIAA high lift prediction workshop. As you can see from the curve, within 10 or 15 minutes of wall clock time, which is the axis along the top, the force has essentially stabilized to its steady state value for the GPU implementation of the solvers, and that's running on just 96 GPUs. To do the same calculation on CPUs, you'd need something like 2,000 cores and at least 5 hours of computing. So the throughput per dollar of hardware cost is higher for GPUs by more than an order of magnitude. The long-term benefit of these high-fidelity first principles-based solution approaches is that they can be applied directly to improve our understanding and our control of numerous engineering applications. By migrating Cascade solvers to GPU-accelerated LES, we can investigate at much more fidelity problems in turbomachinery, propulsion systems, problems in aeroacoustics, where noise prediction and understanding the noise radiation of systems is important, challenges with combustion dynamics, and even classical problems in external aerodynamics. Our commercialization plan for this CFD technology is to establish and support software licenses, both inside the government and commercially. Demonstrations of the technology are ongoing at NavAir, where the team there is directly impacting large programs such as V-22 and CH-53K. We are also exploring opportunities for commercial licenses at OEMs that work with the Navy. Cascade already has commercial licenses in place at some of these companies. In the near term, we plan to expand the licensing of the tools into adjacent markets as well, where motion is central and slow simulation throughput has been a traditionally pacing issue, such as turbomachinery problems, and particularly full-wheel turbomachinery. As the tools continue to mature, we expect use to broaden into aerospace more generally and automotive. If you're interested in increasing both the throughput and the accuracy of your CFD simulation by leveraging Cascade solvers running on GPU-accelerated hardware, I encourage you to reach out to our team. Our contact information is shown on this slide. Thank you.